Hi everybody. So today's video is going to be about task 1.5 from Math 1 Module 1, and we have one learning target today. The learning target is I can evaluate linear and exponential expressions. Now, evaluate means to find a value. So our answers today are going to be output values or values for functions. I want to take a second before we start going into the notes and review function notation, which we originally covered earlier in this module. Function notation is just a way of writing your answer that shows both the input and the output of the function. Now, it's important to realize that function notation will just generally look like this. So on the outside of the parentheses, this is going to be the output variable. For example, if we were measuring the number of boxes that we had, we might make this letter B. It's just the variable that represents the output that we're measuring. Inside of this parentheses is always going to be the input. I remember that because I remember that the input is always inside of the parentheses. And on the other side of the equal sign, so separated from everything else, is going to be the output. And I remember that because the output is always outside of everything else. Just as a reminder, the inputs are always the x values in a function, and the outputs are always the y values in a function. So if I was to read this out loud, I might say f of x equals y. The number of, let's pretend f stands for fish, the number of fish at time x is equal to y. Now, it's important to know that we can find inputs and outputs looking at a variety of representations. We've already learned that we can find inputs and outputs in a table. We know that the inputs of a table are always in the left side column. These are always the inputs. And we know that the outputs in a table are always in the right side column. We also know that on a graph, the inputs are always on the x-axis. And we know that the outputs are always on the y-axis. All we're doing today is we're using inputs and outputs in what's called function notation. So you'll notice here we're using number of minutes and gallons of water. We've got number of minutes and gallons of water. Because we're measuring the gallons of water, that's why this is called a G function. G stands for gallons. It's just the name of what you're measuring. And the input of this function would be inside of the parentheses, which is 2. So this is the input. And the output would be outside of the parentheses, which is the 5. Now, this specific input-output combination is something that we can find in all of the representations. What this is telling me is that when the input is 2, the output is 5. I can see this exact same input-output combination in the table when the input is 2, the output is 5, and on the graph, where when the input is 2, the output is 5, so we have a point on the graph in that location. These are just 3 different ways of representing an input and output relationship. We can do that in a table, we can do it in a graph, and we can do it with function notation. Now we're going to take that today, and we're going to talk about something called evaluating functions. Sometimes what's going to happen is that you will only be given the input of a function. Your job is going to be to find the output. This is called evaluating a function. And we use function notation to do this. Now, evaluating functions might look a little different depending on the representation you're given. So what we're going to go through is an example of evaluating functions when you have a table, evaluating functions when you have a graph, evaluating functions when you have a word problem, and evaluating functions when you have an equation. So we're going to do the same exact task. We're going to evaluate a function each time, but we're going to do that using different representations so that we can see how you might do this in different contexts. So the first example says the table below models the amount of money you have saved each month. We've got our months, which are our inputs, and I know that because it's in the left-hand column. And we've got our amount of money, which is our outputs, and I know that because it's in the right-hand column. Now, the first question is, how much money did you have saved after 3 months? So 3 months is a specific input of the function. What that means is I'm going to look for the number 3 in the months column, which is here, and I'm going to match that up with the output that corresponds, which means my output would be 90. So I would say that I have 90, I don't know, I think probably we're using dollars here, saved after 3 months. Now, let's suppose we want to change this and use function notation instead, because writing out all these words, $90 saved after 3 months, is a lot of words to write out. Let's name this function m of x. You're going to notice we're using the letter m here because we're measuring the amount of money that we have saved. So it makes sense to use m as our output variable. M of 3 would be equal to 90. Because when the input of our function is 3, our output is 90. And we saw that in the table and we wrote it above there. This notation is just a faster way of saying the amount of money after 3 months is $90 rather than having to write out all of these words. Now let's suppose I gave you as a follow-up question, find m of 0. So to find m of 0, what that means is when our input is 0, what is our output? Well, if I look in the table, I can find where the input is 0 is the first row. What that means is I'm looking for this combination of information. So I would say m of 0 is equal to 30 because that's the output. The amount of money after 0 months is 30. Now, when I say explain how you found your answer, it's because I do want to go through some notes on, like, if you ever have to go back and look at this in the future, how did you get that in the first place? Since the 0 is inside the parentheses, it is an input value. So if it's inside the parentheses, it's an input value. So we found 0 in the input column and matched it to an output of 30. Okay, so that kind of summarizes how we would use a table to find input-output combinations. For the next problem in this video, we're going to go through how to go through the same thinking process but with a graph. So the graph below models the number of boxes for every figure number. Just like before, we can tell that the inputs are figure numbers, but this time it's because it's on the bottom on the x-axis, just like we know that the inputs were the left-hand column. And we can also identify the outputs by looking at the label on the vertical axis, the y-axis, and the output is the number of boxes. So in the first part of our question, it says, how many boxes were there in figure number 0? Figure number 0 is an input because figure number is the inputs. So if I find an input of 0 and I match that up to a point on the graph, When the input is 0, the output is 9. So I would say there are 9 boxes in figure number 0. Now, a faster way to write that, rather than writing out all these words, would be function notation. So let's suppose we use the name b of n. Now, the reason we might use the letter b for this function is because we're measuring the number of boxes. So it makes sense to use the letter b, and we might use n instead of x because it's the figure number, which a number starts with the letter n. Saying that there are 9 boxes in figure number 0 means that b, the number of boxes in figure 0, so that's again our same input we had up here, would be 9. The number of boxes in figure 0, same one we had here, would be 9. Now let's suppose that I asked you to find b of 2. Reading this notation, I would see that the input should be 2, and the reason is because it's inside of the parentheses. So on the x-axis, I would find the number 2, and I would match it up to the point on the graph, which has an output of 1. So I would say that the answer would be b of 2 equals 1. Now, explain how we found our answer. So just like before, we started by recognizing that the number 2 was inside the parentheses. So since 2 is inside the parentheses, it is an input value. Therefore, we found 2 on the x-axis and matched it up with the corresponding output value. Now, we're never on a test going to ask you to explain how you found this. I just want to have this part in your notes because I want to make sure that if you ever go back and use this to try to figure out the answer to a question that you're struggling with, you have some idea how you solved this problem in the first place, which might help you with future questions. Let's take a look at the next example. So again, I'm going to talk about inputs and outputs, but this time I'm going to have a word problem. You run a business making birdhouses. You spend $600 to start your business, and it costs you $5 more to make each birdhouse. Now, rather than just jumping straight into finding inputs and outputs, it's going to be a lot easier to do this if we make a table first. That is the strategy that we can always use to help us with word problems, is make a table of values. Now, just like before, we said it's $5 to make each birdhouse. So since we're increasing our value each time we make a birdhouse, our input values are going to be the number of birdhouses. This means that our output values are going to be what we're measuring, or the number of dollars. Or sometimes people call that the cost. So just to start up your business before you even make any birdhouses, you had to spend $600. That means that the first set of values in my table are going to be for 0 birdhouses. I had to spend $600. Now let's talk about what happens for the rest of our business. It's going to cost us $5 for each birdhouse. So when I start with $600 and I make one birdhouse, I have to add $5. When I make another birdhouse, I have to add another $5. When I make another birdhouse, I have to add another $5, which brings me to $615 total. So if my question, the next follow-up question is, what is the cost of making 3 birdhouses? I would find the 3 in the input column, and I would match it up to the cost, which is $615. So I would say $615 to make 3 birdhouses. Now, just like before, what we're going to do now is talk about how to use function notation so that we don't have to write out all those words. Let's say we name this function c of x, and again, we might use the letter c because we're measuring the cost. This means that c of 3, that same input from before, would be $615. Let's say I asked you to find c of 2. Once again, c of 2 would be the input value being 2. So I can go back to my table and find an input of 2 instead of 3 and match that up to 610. So I could say c of 2 is equal to 610. Now, I'm not going to explain how I found my answer here because it's really the same way we found our answer in the previous table problem. So if you ever get stuck, you can go back and look at the explanation that we already wrote for the table problem that we did first. Before we summarize our results, let's talk about what to do if you have an equation. So let's talk about that birdhouse business one more time. This equation models the cost of making birdhouses. So what is the cost of making 15 birdhouses? In other words, find C of 15. Well, if I've got an equation, then rather than turning this into a table or a graph, it is possible to find C of 15 just using the equation. Once again, it's important to know that we want the input in our equation to be 15. Now, if you look at the equation, we see the input is B, and we see another B right here. What that means is that to figure this out, we just need to plug in the 15 for all of those inputs. So I'm going to write C of, I'm going to replace the B with a 15. So instead of this B, I'm putting a 15 equals, now the equation says 5, and then I'm going to replace the B with a 15 plus 600. Now, in order to figure this out, it will be very helpful to have a calculator. So all I'm going to do on my calculator is I'm going to type in 5 parentheses 15 plus 600, which means I get 675. So to finalize my answer, I would say the cost of making 15 birdhouses would be $675. Let's say now we changed it up and we asked you to find C of 10. Once again, we want our input to be 10. Just like here, our input was 15. So we're going to take this same equation and all the places where we see a B or the input, we're going to change it to a 10. So I would say C of 10 is equal to 5 times 10 plus 600. Now I'm going to use my calculator, so I'm going to have 5 times 10, here we go, plus 600, I'm just typing this in, 5 parentheses 10 plus 600, I get 650. So the cost of making 10 birdhouses would be $650. Now let's summarize what we just said. So in summary, if you are given a table and a graph or function notation, how can you find these values? So if this is your table, if this is your graph, let's find D of 2. Okay, D of 2 means that the input should be 2. So I'm going to find the 2 in the input column and match it up to its output. That means that D of 2 should be 11. Now I can do the same thing on a graph. If I want to find D of 2, that means that's the input. So I would find the 2 on the x-axis. I would match it up to its point on the graph, which has a y-coordinate of 11. So once again, I would get D of 2 equals 11. And that should make sense. Since both the table and the graph represent the same information, the answer shouldn't change just because we're doing the problem a different way. Now let's say we're given an equation. If I say D of x is equal to 5x plus 1, find D of 2. What this should tell me is that I want to replace the input with a 2. So in this equation, instead of the x here or the x here, I'm going to put in the number 2. So I have D of 2 equals 5 times 2 plus 1. You'll notice everything was the same except for I just changed the x's to 2's. Now on my calculator, I would type in 5 parentheses 2 plus 1, and I would get 11. So since 5 times 2 plus 1 is 11, I can say that d of 2 equals 11. Now you're going to notice that that answer matches our previous two answers. So because they represent the same thing, all of our answers should be the same. It's just different ways of doing it based on the different representations. Now the last example here is a slight change. You'll notice that this equation looks a little bit different, but we find our answer the same way. If I say find s of 4, that means please make the input value in the equation a 4. So I'm going to find all the inputs. There's one, and then the exponent is another one, and I'm going to replace them with 4's. That means I have s of 4 equals 3 parentheses 2 parentheses to the 4th power. Now, again, your calculator is very helpful here. So one button that I want to make sure that you see, in case you didn't know it was there, was this little arrow. It's called a caret. It makes an exponent. So to type in this equation, I would type 3 parentheses 2 parentheses, and then push the caret button and make it a 4. And if I hit enter, I get 48. So I would say S of 4 equals 48. And that would be my answer. All right, thank you guys so much for watching, and I hope that we can see each other soon.